You're going to read this packet, you're going to listen, this is forces in motion, and as I read that, you'll be able to answer these questions on the yellow piece of paper. Forces in motion. Forces interact with objects to produce motion. Motion can be observed, measured, and described. And down here at the bottom, it says, I wonder, why does a pit crew need to replace a race car's tires several times during the race? Let's turn the page to find out. Here's why. Friction gives the race car traction and allows it to grip the track, but it also produces a lot of heat. The high speed and forceful turns of a race car wear tires out quickly. In this unit, you will explore the big idea, the essential questions, and the investigations of the inquiry flip chart. Okay, let's flip. We are now on page 149. And some of this you will not have to do, but we'll read through it and I'll kind of explain if you need to complete or not. It says, as you read the lesson, figure out the answer to the following question. Write the answer here. You don't need to do this, just think through this. What forces are acting on this cyclist are the forces of balance. That's something we're going to learn when we get later in the reading. Here's some vocab. We're not going to worry about this. It says cause and effect. Some ideas in this lesson are connected by a cause and effect relationship. Why something happens is a cause. What happens as a result of something else is an effect. Active readers look for effects by asking themselves, what happened? They look for causes by asking, why did it happen? We're going to flip to page 150. This is pushing and pulling. You pull on a door to open it. You lift up a backpack. You push on the pedals of a bike to go faster. What is the effect of a force on an object? As you read this page, underline the effects a force can have on an object. The horse and the road it is on both exert a force on the cart. Draw an arrow that shows the direction of the force applied to the cart by the horse. What's happening? Where is the horse taking the cart? Changes in motion all have one thing in common. They require a force, which is a push or pull. Forces can cause an object at rest to move. They can cause a moving object to speed up, slow down, change direction, or stop. Forces can also change an object's shape. Forces are measured with a spring scale in units called newtons. The larger the force, the greater the change it can cause to the motion of an object. Smaller forces cause smaller changes. Sometimes more than one force can act together in a way that does not cause a change in motion. Now we're going to look at page 151. When the rowers pull back on the oars push against the water. Weight is a measure of the force that gravity exerts on an object. You can measure weight with a spring scale. Record the weight shown on the spring scale, which has more weight. You're not going to necessarily be able to see that. You can. If you can see those two measurements, write that there and then answer that question. The water pushes back against the oars. This force causes the boat to move. When the ball hits the floor, the force of the floor makes the ball stop and change its direction movement. When the ball hits a player's hand, when the ball hits a player's hand, the same thing happens. Let's look at page 152. This is two common forces. Over here it says draw an arrow showing the direction of the gravitational force between Earth and the falling flower petals. What do the skydivers in some of the flower petals have in common? They are both falling. What causes this? As you read these pages, circle the sentence that describes a force that causes things to slow down. We're going to look at gravity. Gravity is a force of attraction between two objects. The size of this force increases as the mass of objects increase. It decreases as the distance between the objects increases. Gravity acts on objects even if they are not touching. Large objects such as Earth cause smaller objects such as the skydivers to accelerate quickly. We expect to see things fall towards Earth. However, the force of attraction is the same on both objects. If you place two objects with the same mass in outer space, they will move towards one another. If one object is above the other, the bottom object will appear to fall up as the other falls down. We're on page 153. We're going to read these two captions here. Friction changes the energy of motion into thermal energy. When you use sandpaper to smooth wood, you can feel the temperatures rise. An air hockey table blows air upward. The layer of air reduces the surface friction so the pieces move quickly. We're going to read right in here now. Friction. It is easier to ride your bike on a smooth road or on a muddy trail. Why? Friction is a force that opposes motion. Friction acts between two objects that are touching, such as the bike tires and the road. Friction can also exist between air and a moving object. This is called air resistance. It is easy to slide across smooth ice because it doesn't have much friction. Pulling something across rough sandpaper is a lot harder because there is a lot of friction. In the pictures on this page, circle the places where there is friction between two objects. In the small boxes, write INC if the object is designed to increase friction. So INC if it's increasing friction, and DEC if the object is designed to decrease friction. The tires on this bike are designed to keep the rider from slipping. You have to pedal harder on a rough surface to overcome the force of friction. Let's look at page 154. This is balanced or unbalanced. The tug-of-war teams are both applying forces, so why isn't anyone moving? You're going to draw a circle around a sentence that explains why objects don't always move when a force is applied. When you sit on a chair, the force of gravity pulls you down. The chair pushes you up. You stay in one place because the forces on you are balanced. Balanced forces are forces on an object that are equal in size and opposite in direction. They cancel each other out. The tug-of-war teams in this picture don't move because the forces are balanced. Friction keeps them from sliding. They won't move until one side exerts a larger force. Then the forces are no longer balanced. Unbalanced forces are forces that cause a change in motion. A force must also overcome the force of friction before an object will move. Page 155. We're going to read here and then we'll read down. When a plane flies at a constant velocity, all the forces on the plane are balanced. If they weren't, the plane would speed up, slow down, or gain or lose altitude. The push on the first domino was a blank force that caused it to fall into the next domino. As each domino fell, it transferred the force to the next domino. See if you can figure out what goes in there. The force exerted on this domino by the falling dominoes is balanced by the force of the box. Because the forces are blank, the domino doesn't fall. We're looking at balanced and unbalanced forces. We're going to skip this. The forces on the dominoes are blank when they are standing upright. When a falling domino hits them, the forces become blank and they fall. We're looking at balanced and unbalanced forces. Let's look at page 156. This is push or pull harder. Would you expect a bunt in a baseball to go out of the park? Why or why not? As you read, circle the sentences that explain the relationship between the size of a force and motion. Use forces to explain why the boy can't ring the bell. You can skip that right there. You don't need to worry about that. When the man swings the hammer, he exerts a force on a plate. The plate transfers the force to a piece of metal that rises up the column and rings the bell. The boy swings the same kind of hammer at the same kind of machine. Why doesn't the metal hit the bell? Just think about those there. Let's look at page 157. If you want to make the cue ball knock another ball, that's this one right here. If you want the cue ball to knock another ball into a pocket, you hit the cue ball with a lot of force. This large force makes the cue ball change its velocity or accelerate quickly. It has a lot of energy to transfer to the other ball. The energy causes the ball to accelerate. The greater the force applied to the cue ball, the more force it can transfer to the other ball. A large force will cause a large change in the motion of the other ball. A small force will cause little change. Changes in velocity can also include changes in direction. We're not going to worry about that. We're going to skip this part here. Make sure you've completed the yellow sheet.